All right, welcome back. We're going to be talking about the first and second derivative in calculus. So, literally, the first derivative tells us when things are increasing and when they're decreasing. The second derivative tells us the shape. We call that concavity. Is it concave up or is it concave down? All right, so concave up holds water. If it was raining, it would be holding water. Concave down would be spilling water, or spew is what one my professor used to say. But literally just remember, first derivative increasing or decreasing, second derivative is when it tells us the shape. All right, so we're going to analyze this function here. I do have a graph of that function here, so you can kind of just look at that there. Pretty straightforward. Let's find the first derivative, and let's do that here. That's nothing that you have not done, so this is just going to be 3x squared minus 18x minus 48. That is your first derivative. Okay, cool. The thing about the first derivative is when it's not increasing or decreasing, that's zero, right? So 9 times out of 10, you're going to take the first derivative and set it equal to zero, right? Uh, a lot of time as professors, we get really mad at students because they're like, what are you doing? Well, obviously, you're going to take the first derivative and 9 times out of 10, you're going to set it to zero. So you want to set this to zero to see where it's not increasing or decreasing. And that's really what we call the change in direction. Because when it's not increasing, that's when it's turning from increasing to decreasing or decreasing to increasing. All right, so we're going to set this equal to zero. Um, we're going to go back to ninth grade and do some factoring. This is going to be x squared minus 6x minus 16 here. So we're going to have 3. This is just going to literally be x minus 8, x plus 2. Obviously, if we divide, that 3 would go. So this is just going to be x is equal to 8 and negative 2. So these are what we call your critical values. Okay. Now, a critical point is the same. It's just a point has an x and a y. So if it was the critical point, it would be like 8 and something else, and you just put it back in the function. All right, but right now we're just dealing with critical values. Okay, so at when x is 8, we're gonna see a change in direction, and when you see x is negative 2, that's the change. So those are critical values because that's kind of where we care the most about, like when is it changing direction. So if we go back to our function here, we're going to see here, do you see how that when x is negative 2, that it went from increasing and it changed to decreasing? And this should be 8. Do you see that? So at x is 8, it changed direction. So it was decreasing and increasing. Okay. So how do we find that without a graph? All right. Not too hard at all. So what we do is we just use those critical values. Okay. So we're going to say that we're going to start this off with, say, negative 2 here, and this is going to go all the way to 8, and this is going to go to positive infinity, and this is going to go to negative infinity. And all we need to do is just use a number that is, say, we'll just use this number negative 4, because that's negative 2 all the way back. We can use any number. Negative 4, when we put that or substitute back into the derivative, we should see that that's going to be a number that is going to be um, increasing. All right. So, uh-oh, don't have my calculator with me. I should. Right. So let me just kind of take my time. So we got this here. Um, okay. All right. Cool. So you could see that this is going to be negative 16 times, you got that there. That is going to be 432. So that's 7. So negative and a negative make a positive. Minus this here. These cancel out, so you know the answer is 2. But we don't really care about that number. We look at the sign, so this is increasing. Okay, so I'm going to pick a number between negative 2 and 0, an easy one. Negative 2 and 8, an easy one is 0. So when I put in 0 here, I get negative 48. So I see that that's going to be negative right there. Okay, cool. And then what I'm going to do is I'm literally going to put in here just a positive 4, since those are the same numbers. And as I see that this 48 is going to go with that 40. Let's just put it in. Oh, not positive 4. Excuse me. I got to pick a number that's bigger than 8, that's larger than 8. So I'm just going to use a nice round number like 10, because we like 10s. Okay, so that's going to be, this is going to be 300 minus this. Okay, whatever the number is, we see it's not going to be, it's going to be positive. Okay, so we see that that's there. So we see that that function increases, and then when it gets to negative 2, it's going to decrease. And then when it gets to 8, so after 2, it's going to decrease. Then when it gets to 8, it's going to change direction. All right, well, let's verify that. Okay, cool. So it goes up until it gets to 2, change direction, then it goes negative. It's going to be not negative, but it's going to be decreasing all the way till it goes to 8, and then increasing. You see that? Okay. Cool, no problem. So now let's look at the actual, what we call the inflection points, okay? So an inflection point is where it changes concavity, okay? Where does it change concavity, meaning where is this point right here? This is the inflection point here. Where does that at? All right, so obviously you're going to use what we call the second derivative, okay? And the second derivative is going to be over here. So this is just going to be 6x minus 18. Obviously, we're going to set that equal to 0. Okay, move that over. So x is going to equal to 3. So at 3 is where this function changes concavity. It goes from concave up to down, or down to up. So let's go back here. Let's try to find 3. All right, so we can get really close to 3, but we can see at around 3 is, do you see that it's going from concave down to concave up right at that point right there. Okay, we can even go here and do this here, and we can see, if we kind of zoom in, that's where, this is the point where it kind of changes its concavity. All right, so at this, so that's the inflection value. The inflection point would be is that on there? The inflection, I'll just put it there. So the inflection value is at 3. Okay, that's negative, right? So cool. So we could kind of see here that if I put this point here, 3, at that point is where it's going to change concavity. All right, very simple. All right, cool. And we could also check concavity by putting my critical value, my inflection value there. And I just choose a nice number that's less than 3. Obviously, I'm probably going to put 0. When I put 0 in there, that's negative. Negative means concave down. Let me choose a nice number here. Let me choose 4. 6 times 4 is 24 minus 18, which is just going to be 6, which is a positive. Okay, so it tells me, and I could look at it from negative infinity up till 3, it's going to be concave down. Then when it hits 3, it's going to change concavity and go concave up. And you can see that here. That, see that? That's concave down. Concave up holds water if it's raining. Okay. All right. Cool. Let's do one more. There's another trick to it. So you can also figure out if it's a local max or minimum. Is it the height or is it the lowest change in direction? Okay. All right. So all we have to do is what we did earlier is find the first and second derivative. Okay. Find the first and second derivative. So I'm finding my first derivative here, and then I just find my second derivative, okay, which I already found. Okay, so this is an 18. It should look better. So it's actually called the second derivative test. Okay, so what I want to do is, because it's always more than one way to do things in math, so all I do is find my critical values, -2 and 8. All right, so I got my values of -2 and 8, and I just substitute those into the actual second derivative. Okay, so if I put this here, let's start with -2, and I put that in. All right, I'm going to get -12 minus, which is just going to be -30. When I look at that, I know that it's negative, so I know that that is going to be a maximum. That means that's the top. So it's the opposite. So if the sign is negative, then I know that this at -2, that's a max, meaning it's not going to get any higher than that, right? It's not going to get any higher than that in terms of that change of direction. All right, cool. Let's go here to, let's do the next one. So I'm going to do my other critical value. I'm going to substitute 8 in here. So I'm going to have 6 times 8 minus 18, which is just going to be 48 minus 18, which is 30. Cool. Coincidence, that's the same number. If it's positive, then I know that that is going to be the opposite, which is going to be a minimum down here. Okay, cool. All right. So go ahead and I want you to try this one. Find all the critical points and then tell me if it's a max or a min, and then find the inflection points and the change in concavity. Stop the video and do that then. All right, cool. So let's go here. Let's literally take the first derivative, which is going to be 12x to the third minus 12x squared. What are we going to do? We're going to set that equal to 0 because that's when it changes direction. All right, we're going to factor this out. So this is literally going to be 12x squared. This is going to be x minus 1. All right, so this is literally going to be x is going to be 0 and then a positive 1. Those are my critical values. All right, these are my critical values. Wait, am I spelling that right? All right, these are my, uh-oh. All right, we're just going to keep moving. So these are my critical values. If I want to find the critical points, I put them back in. So let's just do that. So I know that this is going to be 0. When I put 0 into the original function to get the actual points, I'm going to have 0 and 6, right? Because 0, 0. All right. Then I'm going to put a 1 here, 1 to the 4th. That's 3 minus 4, right? So that's 3 minus 4 plus 6, which is going to be negative 1 plus 6, which is going to be, so these are my actual critical points. So if I say critical values, give me the x value. If I say critical point, give me the actual point. Take the x value, plug it or substitute it back into the original function. So let's see, are these going to be, which one of these are going to be a max or a min? So I go now and I go to my second derivative, which is usually easier to find. So this is going to be 36x squared minus 24x. All right. So I'm going to take my second derivative and I'm going to put 0 in here. All right. And when I put 0 in, I have 0, which is a weird kind of point because it kind of tells us, we'll look at it on the graph because 0 is kind of like neither negative or positive, but it's showing us something is there. Okay, cool. So, and you'll see why. All right, then let's go to 1 here. So this is going to be just 36 minus 24, which is going to be 12. So that's positive, which means that should be the opposite, which is going to be a minimum. Okay, let's look at what that looks like. Okay, so this is that function. See, it's a weird kind of function right here, and you could see at 0 and 6 is where it changed direction, but it's not the lowest point, right? And it didn't it kind of leveled, it didn't turn, right? It changed direction, but it didn't really, like, it slowed up. It was decreasing, it leveled out, but it kept decreasing. So that 0 was a weird one when you get, so it's telling me it's changing, but it's not. Okay. Here is negative 1 and 5, which is our lowest point. So this is a value, meaning it changed direction, meaning it went to 0. It was decreasing, then it leveled off, and it's decreasing again. Okay. Now that's why we have to look at the concavity, which is the inflection point. So now let's go ahead and let's look at our inflection point our equation here. We're going to set that equal to 0. Okay, so here we're just going to have 12x minus 3x minus 2. All right, so you can see here the inflection value. So we're going to add 0, and then we're going to have 2. Right, the same thing. If I want to have my inflection point, I will put in that 1, that 0, excuse me, put that back in there, and I'm going to have 6. All right, then I'll have here, and I'll let you put that in there. Cool. So we can see what's happening there. So let's see what's happening with the concavity. Okay, so let's go ahead and look at 0, and we'll look at 2/3. This is going to be positive infinity. This is going to be negative infinity. Cool. So let's use a really simple point like a -1 here. All right. So we put in that -1 there. That's going to be just 36 minus positive 24, which is going to be 60. So it's going to be positive here. right? Which means that it's going to be concave up. All right, now from 0 to there, so we got to use a point, say maybe like 1/3, okay? Or say we can do something like this, okay? We'll put that in there, all right? So obviously you can see that's going to be positive minus that negative. This is going to be negative right here. Wait, let's check the math. Sorry, let's go ahead and let's do the math anyway. So point minus 24. So that's negative. All right. So here we go. This is concave down. We'll just use something like 1 there. So that's going to be positive. Cool. So we should be able to see that. So it's from negative infinity all the way to 0. That is concave up. You can see that it's holding water. Then from that 1 to here, this -2, it's changing direction. So 2/3 is like down here, right? Around here is when it changed. Do you see it changed to concavity? So it was concave down now, it was spilling water, and it changed here to holding water. All right. So that's the first and second derivative. All right. Thank you. Capiche?